Hey guys, we're going to go ahead and get started on our sig fig worksheet and looking at this first example. For numbers 1 through 16, we're going to write the number of sig figs that we have here. This 0 is a sandwich 0. It's between two significant numbers, so that's why it is considered significant. But this 0 is a trailing 0 with no decimal, so that's why it's not significant. You want to make sure that you have your rules for zeros written out here and or in your notebook, or you're going to want the PowerPoint pulled up with the rules. So let's go through each of these, and we're just listing the number of sig figs. So here, these are all non-zero numbers, so there's going to be 5 sig figs. Here, these are trailing zeros, and there's no decimals, so those zeros are not significant. There are only 3 significant digits, 5, 8, and 9. Number 3, leading zeros are not significant, so there are 2 sig figs there. This is a trailing 0, and there's no decimal, so there's 2 sig figs. This is a leading 0, so it is not significant, so there are 4 significant figures there. All of these are leading zeros, so none of those are significant. These 2 are trailing zeros, but there is a decimal. So these 2 zeros are significant. Trailing zeros, you're asking yourself, is there a decimal or is there not? If there's not a decimal and it's a trailing 0, it's not significant. If there is a decimal and there's a trailing 0, then it is significant. So here there's 1, 2, 3, 4, 5 sig figs. These 2 zeros are sandwich zeros, so they are important. There's 4 sig figs here. These are sandwich zeros. They are significant. 6 sig figs. Here's a decimal, so these trailing zeros are significant, so that's 4 total sig figs. These are leading zeros, so they're not significant, so there's only 3 sig figs in number 10. Number 8 here, there's not a decimal, so none of those trailing zeros are significant. So there's only 1 sig fig. Here's a decimal, so that means it was measured, and that trailing 0 is significant. So there are 3 sig figs there. 1, 2, 3. These are sandwich zeros. They're important. 1, 2, 3, 4, 5 sig figs. These are all trailing zeros. There is a decimal, so that means they are important. 1, 2, 3, 4, 5 sig figs. These are leading zeros. They're not important, but that trailing 0 is important because there is a decimal. So there's 1, 2 sig figs. And then this number is different from number 11 because there is a decimal. So all of the zeros are important. So there's 1, 2, 3, 4, 5, 6, 7. There are 8 significant figures in number 13. All right, part 3. Change the following to standard scientific notation. Okay, so we're turning this to scientific notation. When you're doing scientific notation, you want to figure out a number between 1 and 10. So this number is going to be 7.5. And here, that's a large number, so we need our decimal to be greater than 1, or greater than 0. We need it to be positive. So 7.5, if I were to put my decimal right there, I have to move it 3 places to the right to get it to where it's supposed to go. So scientific notation is going to be 7.5 times 10 to the 3. This one, again, we need a number between 1 and 10, so that's going to be 9.865. So let's be careful here. And if we go back to 17, I did not include those zeros because there wasn't a decimal in the problem, which means those zeros are not significant. Your sig figs are what go in scientific notation. So this is 9.8655. We have to include all of those because they're significant. And then we're going to say times 10. If I put my decimal right here, then that means that I would have to move it 2 places to the right to get where it's supposed to go. So times 10 to the 2nd power. Now here, there's not a decimal, So that means none of those zeros are significant. So I'm just going to write 3.87 times 10, and now we count. If my decimal starts here, how many decimals to get it to where it's supposed to be? 1, 2, 3, 4, 5, 6, 7, 8. All right, here's a small number, so that means we're going to be moving our decimal place to the left. So I need to find a number between 1 and 10. So 6.98. The leading zero is not significant. That's why we're not going to put it here. And there's no trailing zero. So 6.98 times 10. If my decimal was here, then I would have to move it to the left one place. So that's 10 to the negative 1. Okay, leading zeros are not significant, but trailing zeros when there is a decimal is significant. So this is going to be 7.00 times 10 to the negative, if my decimal was there, negative 1, 2, 3, 4. We just went back 4 places. Okay, this is 500 with a decimal, so I need to do 5.00 times 10. So if my decimal's here, we go over 1, 2 places to get to where it's supposed to be. And 245.00, those zeros are significant because they're trailing and there's a decimal. So we're going to say 2.4500 times 10 to the 1 to the second power. Okay, so part 4, we're going to go from scientific notation to standard notation. Okay, write it as a number. So if our exponent is positive, we're moving our decimal to the right. If it's negative, we're moving our decimal to the left. So this is going to be 5, and we have to move that decimal place 5 spaces to the right. So 5900. We're going to move it 5 places to the right. 1, 2, 3, 4, 5. Okay. And 6.080 times 10 to the negative 3. So I'm going to write 6080, and since it says that 0 is significant, I need to make sure I write it there. And we're going to go 1, 2, 3 places to the left. Okay. 9 times 10 to the 6. So here's where my decimal's starting. We need to go to the right 6 spaces. 1, 2, 3, 4, 5. Now these are not important, so that's why I'm not putting decimals at the end of the number, because only these 2 were significant. Only these 2 were significant. So we don't have to include a decimal when we're writing it in standard notation. And actually that's why we don't use standard notation a lot when you're dealing with very, very small things and very large things. Scientific notation is a little better. Okay, so I'm going to write my digits out. And if my decimal is here, we got to move 5 spaces to the left. 1, 2, 3, 4, 5. So my decimal goes right there, and I need to fill in these placeholders with zeros. All right. 7,0,5,0,0 times 10 to the 3 means I start here. That's where my decimal's at. So I'm going to start here. I'm going to go to the right 3 spots. So my decimal goes right there. Now this 0 is important to keep because it was right there. All right, last bit. So we're going to write our digits. My decimal starts here, and we're going to go back 4. 1, 2, 3, 4. And we put those zeros in as placeholders. Okay, so we're moving right along. Okay, so remember your rules for adding. Our answer can only have the least number of decimal places. So in this case, it's going to have one decimal place because 7.2 only has one decimal place. So I'm going to add up these numbers. And on my calculator, I get 86.029. But I can only have one decimal place, so that means that's going to be 86.0. All right, so let's do the next one. 486 plus 89.25 plus 5.8. Now that's hard to see, but I'm just typing it right in. That's going to be 581.05, but this one has no decimal places, so that means my answer cannot have any decimal places. So 581 will be my answer. Let's look here. 132 minus 64.38 is 67.62. But I cannot have a decimal place because this has 0 decimal places. So my answer is going to be 68. And we should be putting units. So this is going to be 68 grams, this will be milliliters, and this one is meters. All right, remember with multiplication, again, we're thinking the least, but we're looking at the least total number of sig figs. So here, the least amount of sig figs is 3. This trailing 0 is still important because there's a decimal, and this number has 3 as well. So we're going to multiply these together. We're going to type it in 40.0 times 847.35 divided by 35.7. So I typed it all in, and I get 949.4. There's a lot here. So my answer can only have 3 sig figs in it. So it's going to be 949. We look at the first 3. And now we have to figure out the units of my answer. That kilopascal cancels with that one, so my answer is going to be milliliters, because that's what I'm left with. This must have been a conversion or something. Okay, so here we're dividing. Same rule applies. This has 2 sig figs, so my answer can only have 2 sig figs. So 10.8 divided by 4.0. is 2.7. Well, that's nice. My answer can have 2 sig figs in it. So the answer is 2.7, and let's look at our units. So these don't cancel, so my units are just going to be grams per centimeters cubed. That's actually a unit of density that we'll be looking at next unit. All right, we're multiplying. 35 has 2 sig figs, this has 3 sig figs, and this has 4 sig figs. So my answer can only have 2 sig figs. So 35 times 21.2 times 89.55. When we put all of that in the calculator, we get a really big number. Okay, but we can only have 2 sig figs in our answer, so this is going to be 66. And then, because that 4 keeps that as a 6, and then those have to be replaced as zeros. And my answer is going to be centimeters times centimeters times centimeters, which is centimeters cubed. That's page 15. All right, part 6, round the following to 3 sig figs. So we're just rounding. This one's going to be 98.9. That 9 rounds that number up, or that digit up. This is going to be 70,000. We can't change the number. We're only changing the number of sig figs. So that's grams, that's meters. This 7 made that round up to a 7. This is going to be 5.01. That 9 rounds that up to a 1. Liters. This is going to be 60.3 meters cubed. That 5 makes that 2 round up. Then we're going to have 90.4 meters cubed. That 5 makes the 3 round up. And now this 7 makes the 9 round up. But if we round up one more, we've just reached 100. So instead of 199.75, we're going to be at 200. And let's put the decimal there so that way we have 3 sig figs. If the decimal wasn't there, I would only have 1 sig fig. So that's going to be 200 centimeters. We didn't put the decimal here because if I would have put the decimal, then I would have had 5 sig figs, but we only went 3 sig figs. All right, number 42. A rectangular aquarium is 47.2 centimeters wide, 89 centimeters long, and 65.38 centimeters tall. What is the volume? So to find volume, we have to multiply all of these together. And we have to remember our rules. Using sig figs, we can only have 2 sig figs in our answer because 89 only has 2 sig figs. So let's multiply these together. 47.2 times 89 times 65.38 is equal to, wow, a really big number. Okay, that's what my calculator gives me. But we can only have 2 sig figs. So I want to keep the 2 and the 7 and replace everything with zeros. So 270,000 cubic centimeters is the volume. Now we need to figure out how many liters that is. Well, from our lab, we know that 1 cubic centimeter is equal to 1 milliliter. So we can say 270,000 cubic centimeters is the same as 270,000 milliliters. And to convert, there are 1,000 milliliters in 1 liter. So when I divide that by 1,000, we get 270 liters. All right, number 43. A crime scene is roped off with yellow tape. The rectangular area is 5.6 meters long and 10.75 meters wide. So we're finding area, we're multiplying. 10.75 meters times 5.6 meters means we're going to have 2 sig figs in our answer because 5.6 only has 2 sig figs. So let's multiply that together. 10.75 times 5.6 is 60.2, but I can only have 2 sig figs, so that's going to be 60 meters squared, approximately. All right, we are about done. I know this has been a long video, so I hope you're watching it at like double time or something. Tell me the number of sig figs in each of the following measurements. So this is more repetition here. We have, those are leading zeros, they're not significant. So 1, 2, that's a sandwich 0, it is significant, 3, 4. Okay, then we have, these are trailing zeros, but there is a decimal, so 1, 2, 3, 4, 5. There's not a decimal, so those trailing zeros are not significant. There's only 2 sig figs in number C, or part C. Here there is a decimal, so these trailing zeros are important. There's 5 total sig figs. Leading zeros are never important, so there's 1 sig fig in that number. All of these are sandwich zeros, so there's 1, 2, 3, 4, 5, 6 sig figs. Round the following measurements to indicate a number of sig figs. 5, all of that, to 3 sig figs. So 5.2 and the 9 makes that 8. Round up to a 9. 83 point, this 5 makes that 3, round up to a 4. Oh, crap. We are rounding to 4 sig figs in this one, so it's going to be 83.35. The 2 keeps the 5. All right, now we need 3 sig figs. So these leading zeros are not significant, so 0.004 is significant, 5 is significant, and that 1 will make the 2 stay there. All right, 4 sig figs. So 52 is significant. That 0 is a sandwich. It's significant. The 7 rounds that up to a 2. 1 significant figure. So those are not significant. That 6 will make that become a 10. So actually my number changes to 0.10 instead of 0.09. We're going to have 0.10. And that 0 has to, let's see, that 0 cannot be there anymore because then there would be 2 sig figs. So that's just going to be 0.1 is what that rounds to. So you can see that even when I do these, sometimes you have to rethink how you're looking at your answer. All right, number 3, round the following measurements to 3 sig figs, and then express the answer in scientific notation. Okay, so this is going to be 0.0305. There's our 3 sig figs, and now our answer is 3.05. times 10 to the negative 2. Alright, so 3 sig figs, so 9,300,000. For rounding, that 0 is already significant, so it's going to be significant there as well. So 9,300,000 will be our answer. And in scientific notation, that's going to be 9.30. There's our 3 sig figs times 10. 1, 2, 3, 4, 5, 6. Okay, and if you're ever not sure, you can put that in your calculator, and your calculator will give you, sometimes, depending on the number, it will give you the number in standard form. It can. Alright, so this to 3 sig figs is going to be 460. So there's our 3 sig figs. These are not because they're leading decimals. That one is significant because there is a decimal. So now we write 4.60 times 10 to the negative 3. Alright, this is a really large number. We just need 171,000 will be significant. And notice I can't put a decimal here or it makes all those zeros significant. So this is going to be 1.71 times 10 to the 5th power. Because my decimals here, 1, 2, 3, 4, 5. There we go. Alright, let's follow our rules again. This is adding and subtracting, so my answer can only have 1 decimal place. So I'm going to add them up. 42.602 plus 20.5 plus 2084. Okay, I get a really large number, but I can only have 1 decimal place. So my answer is going to be 2,127.3. Okay, now in multiplying, this entire number has 3 sig figs, so my answer can only have 3 sig figs. 48.12 times 3.10. My answer can only have 3 sig figs, so it's going to be 149. All right, here we have, we need to follow order of operations. So we need to do our subtraction first and then multiply. So when I subtract these two, my answer can only have 1 decimal place. So 420.297 minus 150.7 is, let's rewrite this, 269.6, and then we're going to multiply by 72.719. So my overall